Supply Chain Dynamics Chapter 8, Part 2. Sequential versus concurrent engineering. Suppose that you have a project which takes a design project which has 3 stages: conceptual design, detailed design, and a tooling and prototyping stage. Now, what looks real good, classical, solid, reliable, etc., is where you completely finish the conceptual design and then go through a stage where you say, are all the deliverables there, are they complete, and then move to the second stage and to the third stage. This sounds, almost like you would write the average thesis or whatever. A very messy alternative is where before, sort of halfway, or at least before the conceptual design is finished, you move to you already start the detailed design, get earlier feedback from that, which results in some rework, but also some improvements on the conceptual design, etc., and go back. Typically, the green area here, the extra area, is the extra work that you have here, or the time that you actually save. Now, sequential. Okay, activities are in sequence, and where the downstream phase begins with the finished and frozen specs from the upstream phase. There is really a one-way information transfer, a one-way learning. The detailed design learns from the conceptual design, not the other way around. There is a very low risk, there's a risk of low design quality, because if the concept design is now good, there's no way of feeding that back into the from detailed design to conceptual design. There is, on the other end, also low risk of iterations, because there are no iterations. There is a low risk of rework, because this is all you have. There are long lead times because, if you want to wait until the last bit is completed, often those last 10-20% take the longest time. There is some kind of 80-20 rule. The last 20% take 80% of the time. There is even the rule that the last 20% take 100% of the time. But that's a joke. Long lead times. A high risk of idle time from the engineers, because while the detail engineers are ready to start designing, the concept design is not yet finished, so there will be redundancy of time. And there is easy thing about it is that if this is really a closed, standalone, a modular task, that you don't need a lot of feedback upstream, downstream. Everybody knows what they have to do. Concurrent is the other way around. Activities are done in parallel, where the downstream phase starts with preliminary information from the upstream phase. It's really a two-way information transfer, two-way learning, which stimulates high design quality. But there is a high risk of iteration, while there's almost certainty of iterations. There's a high risk of rework, while there's almost certainty of rework. It's possible that there are short lead times, provided that the time that you lose in rework is smaller than the time you gain from the early start. And there's a low risk of idle time of engineers, because they don't have to wait, they can start immediately. There is a lot of communication and feedback needed between the engineers upstream and downstream. Nowadays we call that knowledge management. So those are the risks, and those are the potential rewards. What works best depends a lot on how uncertain and how complex a project is.